All right. Hello, everyone. Thanks for joining us today. This specific session is all going to be about giving you practical guidance on how you go about building, let's say, an AI agent or agents for semi-autonomous, DBA work. The key phrase here is semi-autonomous. The point being that we want large language models to help us diagnose, but not really blindly start operating databases. That's going to be a lot of emphasis. I'm Jags Ramnarayan. I'm the CTO of MariaDB Cloud. So what are the key takeaways? Where does AI genuinely really help DBAs? And also where it does not? What are those safe boundaries we want to look at? We'll start to look at really how to structure code these DBA agents based on real facts, real data, not just intuition. The point being that what do DBAs do? Well, they observe, they hypothesize based on the observations. Well, in this case, we want to hypothesize using essentially large language models, do verification, finally recommend. We'll go through design and a code walkthrough of real-world DBA agents. And I intend to make that code essentially freely publicly available soon. And then finally, we'll take on this challenge about how do you essentially have conversations, text to SQL conversations on databases, the approach, the challenges, and the demo associated with that. About myself, I've been in sort of this database industry for a very long time, architected and led multiple distributed data platforms. I co-founded 3 data startups. All have exited. The last one actually exited to MariaDB itself. Okay. All right. So why is DBA automation or the DBA workflows a good fit for AI, and also where it can actually be dangerous? So why does it fit well? If you look at DBA work, a lot of it is diagnostics, and it's hypothesis driven. Essentially, you look at data, and given your experience and tacit knowledge, you go through hypothesis or workflow to essentially get to an outcome. And during that process, you obviously depend on rich observable state like metrics, logs, configurations, statuses, things like that, which is all available in databases, but can also be dangerous. Why it can be dangerous? Because production systems are highly stateful and irreversible, and we'll get to this a lot more. And if you make wrong decisions with incomplete information, it can be very challenging. So if there is one single message you want to take from this entire session, it is actually this. Agents assist with reasoning, and it is really still humans, especially for this domain, that take and retain responsibility. So what do DBAs do in reality, right? And I'm just listing a few things here. They do performance tuning, capacity management. How do they do that? They're looking at low query logs. They're looking at saying, did the same queries regress in terms of performance? They start to investigate capacity bottlenecks. Do we have CPU saturation? Do we have an IO bottleneck? They investigate, look at indexing trade-offs, on and on, right? Really do that sort of front and center. That to me is their primary job. Besides that, they want to make sure that the database system remains highly available at all times. How do they do that? They're looking at setting up a replication or replicas, making sure there's no unnecessary lag with replicas. They're making sure that the database cluster is designed in such a fashion that can always fail over. You can look for errors, correct for errors, that sort of thing, right? So sort of topology awareness is how we'll end up doing. And then they're constantly making sure operationally everything is correct. So there's no configuration drift that's causing side effects. They're looking at upgrades, privilege audits, things like that. And there's, of course, lots more. I mean, I'm just focusing on some of those key areas for DBAs. Now, let's try to map that into what it means in terms of real-world agents, AI agents. So I'm just putting those are like 4 buckets right now for 4 specific agents we'll cover later on. Remember, we want agents to fundamentally recommend and explain, not really mutate production state. Why? I'll get to that in a second. So 4 buckets, one being performance diagnostics. How do you do that? You're looking at slow query logs. You're doing an explain on slow query logs. You might rely on system metrics in performance schema, sysschema, MySQL schema. You might be looking at live workloads. By the way, one thing I should note is I use these phrases with a very MySQL MariaDB context. So when I say sysschema, MySQL schema, of course, are equivalent in Postgres, system tables, and so on and so forth in other databases. One other area would be availability, where we're looking at, whether there is replicas have replication lag, whether it's synchronous, asynchronous replication. Do we have error states in them? How do we interpret that? And what kind of recommendations can we have, right? Configuration management, understanding what and how the database is configured, what the correlations are. For instance, if you change the buffer pool sort of configurations, what exactly are the side effects in terms of concurrency, in terms of I/O, those sorts of things. And finally, which is a really important area for DBAs, I noticed that, is the ability to constantly generate SQL on real-world custom databases, right? This is where you're constantly figuring out how to have conversations with these databases so that you have a way to generate SQL, optimize SQL, and also being able to know about the semantics of these databases really, really well. Right. So I'm going to spend a chunk of my time on that SQL generation part also. If you just look at the definition of what an agent is out in the marketplace, you would notice that the definition always uses the term that agents fundamentally analyze, decompose, and essentially take decisions autonomously. I don't think that applies specifically today to the DBA world, right? So while the claim might be true for a number of domains, specifically for what we're talking about DBA AI, I don't think. And the fundamental reason is very straightforward. Large language models, for that model, anything that's based on transformer models, which is a prevalent model, they're probabilistic in nature, right? The term they use is it's autoregressive. Effectively, what that means is the deep learning model essentially at all times takes the context, which is text, and at any given iteration, it only produces a single predicted word, which is a single word, and then loops back into the model to predict the next word, and so on and so forth. Every word that's predicted, it's purely a mathematical model, so it's purely based on probability. In other words, it's more like saying you can ask the same question twice at completely 2 different times, and you might get completely different answers. So that's where you have to be careful about the fact that it's non-deterministic in nature. On top of that, when you look at databases, there's a lot of hidden state, right? That can skew the LLM's perception of the reality, and it can come up with wrong answers. And once you take an automated action, it's quite often with databases is irreversible. It can be very dangerous, right? So why is it that databases is challenging to get full autonomous behavior? Simple fact is the state is extremely large, right? In a database, in any open source modern day database, there are at least 500 plus configuration variables. That's a single database server. If you have multiple database servers, you deal with configuration potentially for each of those servers. There's a lot of live status state. For instance, with MariaDB, there are like 590, status variables, counters, gauges, what have you. Then on top of that, you have time series state that's defining what's going on in the database with performance schema. You have metadata and MySQL schema, on and on. And then if you have a replication, you have to worry about cross-node causality, and essentially the state explodes. On top of that, you really don't have historical context, right? What exactly happened in terms of slow queries, in terms of these actual variables, let's say a week ago, a month ago, and that's the correlation that's really important for you. You just don't have that. The implication is that when you essentially look at, take the state of the database, even look at the current logs, it's not the complete truth. So you never have the full information and the full context ever to make thorough, complete, verified decisions all the way. Okay, so let's look at what exactly are AI agents? So these are the 4 bullets I use to define. Agents are task specific, and they always aim for a very specific goal or an outcome. More narrow the task, the more accurate the behavior is going to look like. Given a complex question, an agent can reason with that question, break it down into a sequence of steps, logical steps. Each of the steps can be driven through data presented to it. Agents use tool to take actions. This is how you connect. Tool connects essentially an agent to the real world data, right? So we can put guardrails, we can essentially provide connections to actual databases, provide data and all that. And the other point is the self-reflection, which is probably the most relevant thing. It's the ability to sort of detect, sense errors, and loop back to finally synthesize good answers. So what you see at the bottom is a very simplified view into an agent, let's say a DBA, a portion of the DBA agent that's saying, how to analyze and figure out the top 5 slow queries, analyze it, and provide some from some tuning guidelines, right? So simple loop could be, the agent now has to check is slow query logging on. If it's on, is it going to a table? Is it going to files? Okay, I figured that out. Then I got to look at and figure out which are the top 5 slow queries. Then a step 3 could be to explain with analyze or other options. Take the results, which can themselves be complex, and then analyze using the LLM's prior knowledge, and then synthesize a final result. So essentially, it's constantly going through each step, reasoning with the results, potentially changing the steps itself on the fly to do what it needs to do. So the key here is, whenever you use an LLM for such operations, my strong recommendation is to use a reasoning LLM. Yes, it's more expensive, like a reasoning LLM would be a GPT 5.2, a Gemini 3 Pro, and then a variety of open source LLMs. Obviously, these LLM now has to rely on tools, like I said, and the tool could be as simple as, hey, just run this specific SQL I generated on a target database and return me some result back. Okay, so let's take a peek at a multi-agent DBA agent. So before we go into the code and look at that, so this is a very rough architecture for a very junior, let's say, DBA agent, right? Just highlighting a few of the agents that you would need. In reality, there's a lot more complexity to build out a full-fledged, I would say, DBA automation, AI-based automation. So as an example, we want the slow query agent. The slow query agent is reading the slow query logs and looking at performance statistics, essentially relies on a number of tools to get to the right data, right? Historical metrics, you might need buffer pool statistics. Current running agent is what's currently happening within the system, on and on, right? I mean, there are a bunch of agents. So the key is you have these agents that are using LLMs. Agents rely on 2 primary things, tools and guardrails, right? Tools is how you get to the data itself that you need for the agent to actually infer the right, make the right heuristic judgments. And guardrails is how you essentially protect against sensitive data, make sure that when you ever generate SQL, you're not doing SQL injection, right? You're not suddenly mutating the database itself or dropping something. You want to really be sure that never happens. You never want to pass in sensitive data potentially into the LLM, things like that, right? The range of guardrails. Every agent has its own input and output guardrails. You'll see that, and hence this common infrastructure to configuration management, all that. And these tools or these agents effectively are now interacting with external systems, right? For instance, you are looking for historical log that's sitting in Datadog, or obviously interacting with OpenAI or your LLM to actually get the LLM behavior. And what you see is that there are a bunch of agents, and then there is agent-to-agent interaction. So there's an orchestration agent that's sitting on top. So if you're asking questions like, I want to understand the overall health, is essentially orchestrating, taking that input question, breaking it apart into a set of, let's say, the intent and tasks. And for each of those tasks, it might then use these underlying agents as if they are the tools. So you see the hierarchical composition of agents, right? Agents can rely on other agents as tools. Agents can then rely on tools themselves, so on and so forth, to construct a sequence of interactions with the LLM, with the context we have, to generate an outcome that we want. Okay. So with that, let's actually look at some code. Before I look at the code, I just want to give you a flavor for, well, how do the agents really perform in real world? So this is that, agent that has been vibe coded, and I'll open source it pretty shortly here. The agent also exposes an MCP server. I'm not going to get into what an MCP server is, but that's a way to kind of get your agents working in modern day IDEs. At any IDE that supports AI, which most of them now do, you can simply connect your agent directly and start interacting with it. So I'm not typing a question right now, because a question, let's say, like, can you report on the overall health of our database cluster, can take well over a minute to come up with a response, because it's taking many turns with the LLM, and it can be slow, especially with the reasoning LLM. So anyway, so let's look at I just ran it just a few minutes before. So here are the results, right? I have a cluster running inside MariaDB Cloud. So it's come back and given us a whole bunch of information about the environment, its resource utilization in terms of CPU, how much of the disk volume has been used, the log volume, what's going on with the replication, error logs, performance metrics, on and on, right? So let's actually scroll down locking behavior. Let's see if it's come up with any specific recommendations. So here it is. It's identified, here are the issues and recommendations, high, medium priority, right? Actually, my database, when I ran it, was pretty much idle, so there wasn't really much going on. But as you can see here, the first thing is that it said that, hey, there is an elevated temporary table usage. So there's a lot of disk spilling going on. Yes, I had run a lot of sort-based queries, and my database is really small. So it's identifying, saying that consider tuning. That's really good. Lock waits were going on because some of the queries were really expensive that I was running. So you might want to look at what's causing those lock waits to happen. Bin log retention is short. I did change the bin log. In other words, it's just simply saying that, hey, you're retaining bin logs only for a single day, which basically means that if at all your primary were to go out for a while, or replica was down for an entire day, and you have to reconstruct a new database, the reconstruction might have challenges. Anyway, so that's really good. That you got a sense for, like, what's going on, right? So you can ask overall health related questions, or of course you can ask very specific questions like, I want to look at the slow queries for the last hour, things like that. So let's actually look at the code here. I'll just spend a couple of minutes here real quickly. So the entire sort of vibe coded agent has been built using the OpenAI's new agent SDK. Strong recommendation is, if you're building agents, use one of the popular frameworks, a LangChain, a Llama Index, a Crew AI, OpenAI's SDK. I mean, there's like a million out there now. So, I mean, if you look at the agent creation, it's rather really straightforward, right? I mean, all it is like I said, agent essentially takes, of course, a model. Which model do you want, which LLM do you want to use? The meat of an agent is really the system prompt, and we'll show it in a second. And then the agent essentially relies on a set of tools. It's like, hey, how do I read the slow query log file? How do I get the performance metrics for the query? How do I get the buffer pool statistics? That's the tools I'm using right now. Let's actually, and then there are guardrails, right? These guardrails are also functions that gets invoked before and after LLM interactions. So if you look at the meat of this is really this pretty big system prompt. I won't go through all of it, but some of the clear guidelines is that this is where you're instructing the LLM to do certain things, not do certain things. Always make sure you're doing a set of things that you deem important, things like that. So one of the most obvious things is always tell the agent, saying that my context is this database, and you should assume that you're a full specialist on that domain specifically. The good news is that large language models have very deep understanding of open source databases, right? Especially MySQL, Postgres, so on and so forth, and all popular databases. So I won't go through the details. It's primarily identifying what your jobs are. One of the things I'm telling is that, hey, never invent any data. Don't come up with stuff in your head, right? Only use the tools that provide, nothing else ever. In our case, when it's saying we want to do slope query analysis, What is obviously relevant is, well, how do I get the context for slow queries? Is the slow queries on? What kind of slow queries are we logging? Are there patterns? Where is it going? Things like that. I'm telling it very explicitly. The slow query logs could actually be very, very big, right? You could have had like slow queries build up for a pretty long period of time, and you're looking at hundreds of thousands of slow queries being logged. So you won't look for patterns, is where I'm saying, well, how do you aggregate and look for patterns itself? On and on. And this is lots of details around guardrails. How do you sample? How do you canonicalize so that we understand the patterns? And then finally, how do you do deep analysis for query pattern? Now, one thing to note is that my context is very detailed and it's been very deliberate, so that even if I switch to a less powerful LLM, the context still prevails. Now, you don't necessarily have to go through this degree of depth in your context. LLMs are powerful enough to actually know what to do pretty well. Okay, so you guys get the sense for the context and sort of the system prompt, which is a key. And finally, I always say that you always have to prescribe, saying that when you produce an output, how do you actually produce that output? Sometimes you want that output in a structured form, especially if an API in front, so you can actually define what the structure needs to look like also. Here are the tools for this agent, rather very straightforward. Execute SQL, that sort of thing, right? I won't go through the details. And here is the agent that's the orchestration agent. And what you'd notice is that in this case, the agent's tools are nothing but these other agents, right? Analyze slow queries, analyze running queries, things like that. Okay. And that's about all I wanted to show there. All right, so let's go back to the presentation. Okay, so now I'm going to spend about 8-10 minutes on this rather complex problem of how do you enable conversations. Now there are lots of analytical products like Snowflake's Cortex that do text to SQL, right, really well. But I do think that most of the modern databases, especially as we progress in the future, will start to enable text to SQL natively. They may not be as sophisticated as what you might have in a purely analytics database that's targeting analysts. But I think this is also very relevant for DBAs and developers so that they can get really, really productive. Because I see that all the time. DBAs constantly want to either generate queries given some natural language questions people are asking, or optimize complex queries. Even there, you really need a good understanding of the data itself. Or you're generating, analyzing data for quality or generating ad hoc reports, all that. The key sort of takeaway here is that the temptation is to create your own application side agent to generate SQL. The truth is that generating good quality SQL on real world databases is extremely difficult to do because the semantics gets lost and a lot of times the SQL is bad. So the best is to do these agents that are very close to the database and truly understand the database semantics, right? And then you can consume it in other agents on that application side. Why is generating text to SQL doing, text to SQL in real world database very difficult? Some of the reasons are very obvious, right? Real world databases have hundreds of tables, cryptic column names, missing relationship. There are implicit relationships. The data is dirty. It's simply messy, right? And accuracy, if you're asking a domain question, requires true understanding of the semantics and the real domain language and the language the business guys use when they talk to actually this data, right? So the schema constraints, data samples matter for LLMs. And consistency is also an headache. One way a lot of folks attack it is to sort of say like, hey, let's actually take the schema metadata and stuff like that, build a RAG pipeline outside where you need a vector database. And all of a sudden, this is data that's metadata that's potentially also changing, right? All of a sudden, if you shove it into a vector store, how are you going to maintain consistency with the database changes in real time? And on top of that, with agents, there's this notion of short-term and long-term memory. I'm not going to get into that, but that's also state that's very relevant for it to construct a SQL. And if that state becomes stale, you have wrong SQL generated. So lots of those kinds of concerns. Okay. All right. So I'm not essentially, I don't have an open source anything on this semantic, what we're calling a semantic database agents. It's part of MariaDB Cloud. And there are two key things in the way we have implemented it. It's no code. Essentially, you construct these custom agents on your databases without writing any code at all, right? We do the entire automation in the RAG pipeline ourselves. And it essentially automatically, we have a UI that allows you to build this context on the fly, right? And you can modify, tune this context. And that there's a really, really important step that you essentially add missing semantics, define terms, things like that. That's really, really relevant. So human has to be in the loop to do that. And then you kind of iteratively in the UI itself, which is nothing but a chatbot, if you may, a chat assistant, you iteratively train and then finally publish it, which gets exposed through an API. There are also some guardrails, security, and all that sort of stuff. And then finally, like in this domain, given that you're generating SQL with, you can never have the full context because the LLMs are never provided the real data itself, right? Maybe samples and, it's also hidden, sensitive data is hidden out. The ability to be deterministic, in other words, avoiding false positives was really important. So we have an online evaluation mechanism so that once we produce, let's say, given the text, the SQL, how do we know how good or accurate that SQL is? Relevancy, faithfulness, but more importantly, does it really answer the question correctly? So we have an online evaluation that avoids false positives, but not necessarily false negatives. Okay, so let's actually look at this through again what we have built. So this is the MariaDB Cloud dashboard. I won't get into stuff here, but let's just focus on just the AI agents part of it. So the idea behind this is you just come in the UI and you're just creating agents. There's a video that explains the concepts and things like that. But the key here is that you start off by picking your data source and then providing a concise description of the purpose behind the agent. What's in scope, what's not in scope. Again, as I said, the key here is keep it narrow. If you want to create an agent that's spanning hundreds of tables, just don't do it, right? You can get into a lot of complexity. Now you can design the framework to actually do graph manipulations, things like that. But generally speaking, I think more constrained your agent is, the better you are. You can that's the key message. So you kind of start off with a description, and then you go next, and it automatically essentially generates a context by again using the LLM to understand anything and everything about the database itself. I'm not going to create it. I've already created it. It takes 30 seconds to a minute to create it. So as you can see, the agent I have created is essentially provides insights on movies. I mean, it's the IMDb publicly available database, movies, actors, roles, blah, 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 that sort of thing. And in this case, given the description, it has essentially picked up these 11 odd tables. And for each table, this is what we do. Like we've synthesized the actual semantic meaning of like what does this table really contain or do, and if there are any rules such as encoded some sample rows, the sensitive rows, you can actually obfuscate that. And it does actually semantically index some columns. So I'm not going to get into the details, but think about it as like if you have strings that get used in where clauses, essentially filters, you're not going to have real world users express that name in the exact correct way, right? There are going to be spelling errors. They're going to express in different ways. The semantic index allows us to construct those where clauses very precisely. Okay. So you can select, deselect columns, blah, blah, all that. You can add tables, remove tables and all that. So we have this agent up and ready to go. So let's give it a try. Let's say we want to list the top 5 movies with, let's say, Tom Hanks from the, let's say, 80s, right? Hopefully my database is connected and it work. So here, you have choice around which LLM to use. There are other options as to specifying the SQL limit. Do you want to take a single turn or many turns? All that sort of stuff. Okay. Yeah, normally this would be a fast. Okay, there you go. It's a little slow today. We always give you back a response. By the way, this is all structured response. We're using the API, so you can get the actual SQL. You can actually get an evaluation score that tells you, how good that answer is. So if the score is below a certain sort of, it's scored between 1 and 5, 5 being the highest. If it's below 4, you could just reject it, or if it's not even 5, you could reject it, that sort of thing. You can continue the conversation, right? Okay. All righty. Yeah, I mean, I'm running low on time, but anyway, you guys get the gist of it, right? It's essentially doing queries. It can do one or more queries. It can do evaluation, and there's a lot of tuning options, right? There's things like giving golden queries as examples. All of that gets used to produce accurate answers. Okay, so let's go back to the presentation. So what's going on behind the scenes? Just very briefly, right? Given that you've described essentially the name and the description of the agent, we use that to determine intent. We grab the metadata data samples to identify candidate tables. Then we might essentially generate the semantics description. Well, we always do that. Then you can essentially tune the tables, prune, add semantics, that sort of thing. Then we also figure out which are the data points or fields that we use to actually do semantic indexing, which is the thing I said, and we put all that together to generate the full context, and that itself could also get stored into the vector store itself, right? So essentially, it's an iterative process to build out the context for a agent by understanding the tables, but also allowing the human to actually optimize it. So this is a runtime, right? I won't go through the details here at all, but there's a whole range of things that's going on to produce that final answer that the agent produces. So just in a nutshell, if you're doing text to SQL agents, some very basic best practices, right? Limit the scope of the agent. Don't go beyond 10 tables. Don't, if the tables are very, very wide, just pick the essential columns you need. You probably should be vector indexing this metadata so that you can only retrieve just the right context about the tables. You can use vector indexing. You can do, like I said, I touched on before, you can actually construct the knowledge graph and actually vector index that knowledge graph itself. So you pull out the right tables, especially if relationships are not understood really well. If there are too many complex joins, use views, define views, always define synonyms the way business users call entities. Column level semantics is actually very, very key. Also it's relevant to state what sort of scope, because LLMs are notorious to be sycophantic, right? They will try to answer the question whether they can or not. So if you very explicitly say, hey, don't do these kinds of things, this is out of scope, then it behaves much better. Data samples are good, obfuscate sensitive data, test iteratively with your users, and really allow the users to tell you what makes up good answers and the good SQL, and then register those as golden SQL. Okay, so that's about it, folks. Thank you very much. MariaDB serverless is available for free for development. It's a perpetual free tier. And then the AI agents are built into it, that there is DBA developer agents and the custom agents. You can reach out to me anytime. Thank you very much.